Hey, in this video we'll be talking about the rule of three in C++ and a related topic called RAII, and I'll explain what that is once we get to it. So I'm in Visual Studio and I made a class. It's just called Array Holder. I've set up some starter code here, so I create a couple of these Array Holder objects. Now the array holder class, it's just meant to represent any kind of class that has heap memory that it allocates. So array holder allocates some memory right up front in its constructor using the new operator, and it also provides a couple of accessor functions, operator square brackets, so that you can treat it kind of like it's an array, just using square brackets, using an index, a size function so that you can know how many elements are in this array. So there's something missing here, and you should pick that up immediately. When we are allocating heap memory, we need to deallocate it somewhere. So what we should do here is create a destructor. All right. Using tilde array holder, and delete that memory that we allocated. Great. So this makes sure that we avoid a memory leak. But this is not everything that we need to do in order to carefully take care of this memory that we allocated. What we've done here, what I've done, is that I've put the array in the private section here so that other programmers can't touch this array. They have to use the interface that I provide publicly. However, there are still ways for this to be used incorrectly and cause some serious problems. So let me demonstrate that here. I have created an array holder A and an array holder B, and at the end of this function, both of these objects are going to be destroyed. They're allocated on the stack, but each one of these objects then allocates memory on the heap, and when it gets to the end of the function, they'll call delete on their heap allocated memory. But there's a problem if I do something like this. C++ automatically generates an assignment operator for classes, and it does a shallow copy. So all of the variables just get copied directly over, their values, and that includes pointers. So in array holder, this array is a pointer. It's a pointer to an array, and that memory address is going to be copied from one of these objects to the other. They originally start off having two separate arrays, but once I do this assignment, they're pointing at the very same array, and if I run this, problems happen. All right. Triggered a breakpoint. So it crashed because at the end of this function, B gets destroyed and it frees its memory, and then A gets destroyed and it frees its memory. But since they're pointing at the same piece of memory, it's getting freed twice, and that memory that B originally had is being leaked. So we lose access to that as well. So this is a problem, and this is what the rule of three tries to solve. It's a rule of thumb that whenever you create or implement one of three functions, three special functions, you probably should be implementing all three of them. One of those functions is a destructor. A destructor indicates that there's some cleaning up you have to do, and if that cleaning up is not done, then you have not really done all of your job in successfully destroying this object. So in our case, we have this array that needs to be cleaned up. And just the fact that we need to clean it up means that if there was an assignment that does a shallow copy, then it's not going to clean up correctly. So the rule of three says if you implement a destructor a copy constructor or a copy assignment operator, you should do all three. There we go. All right, so actually in modern versions of C++, there are more features added, and there's a different rule in place, another rule of thumb to follow. But this one is the basic one that gets the point across. If we implement this destructor, it means we probably need to do those others in order to make sure that this memory is not fooled around with. So a copy constructor is the other one of them we need to make. So it's going to be a constructor, and what makes it a copy constructor is that it takes an argument of the same class. So I'm going to declare it as a constant argument, array holder, and I'm making it a constant reference. So we only make a copy of it if we need to, which shouldn't be necessary here. Okay, let me call it other. And here is where we have to define how to do a deep copy of this other object. So size is fine. I can get my size from the other size. Array, however, needs to be a little different. In this case, I don't think I need to reallocate. I don't need to delete my array and make a new one. I know that they're the same size, but we could go through all of that. Delete my old array, make a new array of the right size, and then we can copy over everything. Size. All right, let's get all of those values for our array from other array. Okay, there we go. So now I've successfully, oh, I don't have to delete my array. Hold on. I forgot about this. This delete is unnecessary because this is in the constructor and I haven't even put any value into array yet. This is what's important for my the other function. So let me hold on to that for now. So this is the initialization of that array in the first place. Okay, so that's my copy constructor. All right, and then I need a copy assignment operator. So the assignment operator is the equals sign. Operator equals, and the return type here should be whatever it evaluates to when you do an assignment. And when I say b equals a, I should be returning a reference to whatever got assigned into. So we need to return a reference to an array holder. This is a copy assignment operator, so it needs to take an array holder as its argument. There we go. This is the one. So now I'll just grab all this because it's very, very similar. There, that's what I need. So I need to delete the array in this one because the assignment operator will operate on two objects that are already constructed. They've already initialized their arrays, so I need to delete that memory before I move on. All right, copy assignment. There we go. So that's the rule of three. I need to have all three of these so that I can safely run code like this. Make sure we got that. Must return a value. All right, so I forgot my return statement here. We should return this object. We can dereference this pointer to get this object. And the other one, yep, that's fine. Okay, let's see it now. Cool. All right, it runs through, does not crash. All right, so this leads us into this topic of RAII. That stands for Resource Acquisition is initialization. That's why we abbreviate it, because it's kind of a lot. So RAII, resource acquisition is initialization. There we go. So this is a broader concept than what I'm doing here, but this is a very simple example of it. I know now, whenever I create an array holder, it does everything it needs to do behind the scenes and hides that from me. So I don't have to think about it. It acquires some memory as a resource, and it releases that resource when it's all done with it. So with RAII, you'll often see like file handles or memory or objects being created in a constructor and being cleaned up in a destructor. And that means when you use the objects, you don't have to worry about memory at all. I can do whatever I want with these objects, and they'll take care of their internal memory. Sort of like the built-in string class. We know that the string class can expand to fit any size string. That means it has to allocate its own memory. But we don't ever tell it, hey, string, you need to delete yourself, or anything like that. We just let it get destroyed normally. All right, and that's all I have here. So I'll see you next time.